Hello, in this video we will discuss the mathematics of a parabola and some of its real-life applications. So a parabola is the set of all points on a plane that are equidistant to a point and a line in the plane. So this point on the parabola is equidistant from the focus as it is to the directrix, and same as this point.
A practical application of parabolas is seen in basketball as shown by this diagram. When shooting a ball into a basket, the player has to take into account the angle in which they're shooting, which is the trajectory, and the force that they're applying to the ball, and the gravity.
So parabolas are commonly created by projectile motion, where an object is endowed with a constant horizontal speed, which remains constant throughout its flight. And it also has a constant acceleration downward created by gravity. The horizontal speed of the object is indicated by the length of the horizontal arrow. So notice how it stays the same throughout the entire flight. So let's say this object is going at 5 meters per second throughout the entire thing. So here, it will also be going at 5 meters per second, as well as here, and here. However, due to gravity, the object will not have a constant y velocity. Instead, it will have a constant downward acceleration of 9.8 meters per second squared. Due to that, as the object goes forward and gets higher, the upward speed will decrease until it reaches 0 at the peak. And then it will begin to accelerate downward and go faster and faster downward as it moves on. So the trajectories are symmetrical, and they're reflected about this vertical axis, where the center is at the top, where the object has 0 velocity upwards or downwards, is the center of its path. So it is reflected. So at each height, since it has a vertical speed of 5 meters per second here, it'll accelerate to 5 meters per second here as it comes down. Same here, as it was going up at 2.5 meters per second here, it will go downwards at 2.5 meters per second at this point.
Okay, so here on the board is an equation of a parabola. So to find the vertex of that parabola, you take this 3 and this 8 right here. So you have the value of the vertex as -3 and 8. Also, it is important to remember when evaluating an equation of a parabola to remember that the value inside of the parentheses is always the opposite of what is shown. So if you have a +3 here, that means it's actually a -3.
Equations of parabolas will follow the form y equals a times x minus h squared plus k, where h and k are the x and y coordinates of the vertex, as shown right here. Notice how the h inside the parentheses is negative, so the sign must be flipped before finding the coordinates of the vertex. Alternatively, to avoid the switch of the signs of the x value of the vertex, equations may be written as y minus k equals a x minus h squared, so that both h and k are negative and they both must be flipped to avoid confusion. However, when writing an equation using the function notation, it is unorthodox to put anything other than the function notation on the left side of the equation. So the format using the k on the right is favored.
Okay, so a way that the parabola is used in life today is in a headlight. So there will be a little light emitting light to the going in the opposite direction, and then there's like a mirror on this side, and it takes that light and it reflects it out. And here's an enlarged version of that. So the parabola has a very interesting reflexive property. Recall the law of reflection, which states that the angle of incidence is equal to the angle of reflection measured from the normal. Recall also that the normal is perpendicular to the surface. The reflective property of the parabola has numerous practical applications. Since light is a wave, if a light source is placed at the focus of a paraboloid, the result will be a focused beam of light emerging outward along the direction of the axis, like so. This is how flashlights, headlights, and searchlights work.
In order to find the equation of a parabolic equation, you have to use the distance formula. From the definition of a parabola, any of the points on the curve should be equidistant from the focus as to the directrix. As seen in this problem, our directrix is at x equals 2, and our focus is at 2, 4. For this problem, I have drawn the point C at x, y. In order to find the equation, we have to set the distances of ci to C focus. So x, y minus x2 is equal to square root of xy minus 2, 4. If you square both sides, you are left with y minus 2 squared because the x's cancel out, and equals x minus 2 squared plus y minus 4 squared. If you factor y minus 2 squared, you get y squared minus 4y plus 4. And if you FOIL y minus 4 squared, you get y squared minus 8y plus 16. Y squares cancel out, and you're left with 4y minus 12 equals x minus 2 squared. If you take out a 4, you get 4 parentheses y minus 3 parentheses equals x minus 2 squared. You then divide by 4 on both sides to get y minus 3 equals 1/4 times y minus 2 squared. For the final step, you add 3 to the other side, and you're left with y equals 1/4 x minus 2 squared plus 3.